Hello, welcome back. This is the fourth section of the series. Now that we've learned how to build a game framework and use it to make a single-player game, it's time to advance to the next level and tackle multiplayer. So, in this section of the course, we'll look at how to convert our single-player game into a multiplayer game, focusing on Unity's core networking concepts by making our player ready for network play. In this video, we'll focus on the basics of multiplayer implementation. We'll implement a standard Unity Network Manager, then use Unity's networking library to convert our player and our weapons to be network aware. We'll do this in 5 steps, starting with implementing the Network Manager. Then we'll get our player onto the network. Once we can spawn our player in a multiplayer game, we'll make that player network aware so that it can interact in a multiplayer game. Next, we'll modify our weapons classes and our player controller so that we can fire weapons over the network. Finally, we'll move health tracking and physics collision server-side so that they can run securely in a multiplayer game. Are you ready? Let's begin. Let's start by discussing the basic concepts of Unity networking. In Unity networking, there are 3 types of entities connected to the game. A server, which has authority over most of the goings-on in the game. A client, which connects to the server and normally has authority only over its local player. And, when there is no dedicated server, a host, a combination of server and local client that both share authority over elements of the game. A client can only directly affect its own objects. That is, it only has authority over its own player object. The server, however, can directly affect every object in the world because it runs the server scene, which is like the official version of the game scene. Half the task of implementing multiplayer using Unity's high-level API is understanding when the methods of your script should be called on a server or on the local client. But that's not as complicated as it might seem. The basic rule of thumb is, if it has to happen for everyone, it happens on the server. If it only has to happen for the player that was affected, it should run on that player's client. Maybe it's best to illustrate through example, so why don't we jump into the actual game. We're using the Section 4 Start version of the project to begin with here, so load that up in Unity now if you haven't. First, we'll need a server. The easiest way to implement a server is to use Unity's Network Manager component. The Network Manager handles keeping everything in sync as long as it's set up appropriately. So first, let's create a new object in our scene and name it Network Manager. Now on that object, let's add a Network Manager component. Next, we'll add the Network HUD component as well. The Network Manager HUD component is a simple script that implements a debug Unity GUI interface for our server. We can use this to connect to a server or to host a server when we play. However, when it comes time to ship a multiplayer game, you'll want to build your own interface into multiplayer. Thankfully, both the Network Manager and the Network Manager HUD component are open source, so you're free to modify them or use them as a starting point for your own implementation. In our case though, these debug default versions will work just fine. Now, we still have a little setup to do here, but we can essentially tick the first task off our list. We now have a Network Manager implemented in scene. See? Not as difficult as it seemed it would be, right? Let's get our player onto the network next. In Unity, go to Scripts, Framework, Character, and Open Base Character. At the end of the using directives at the top of the file, we're going to add using unityengine.networking. This will give us access to the networking API. Next, we're going to make this class inherit from network behavior instead of mono behavior. This will tell Unity that our character class needs to be network aware. Now let's save the file and go back to Unity. In the project view, go to Content, Prefabs, and find the player prefab. In the inspector view for the player prefab, add a network identity component. We also want to make sure that on that component, local player authority is checked. Now, select the Network Manager in our scene hierarchy and expand the Spawn Info section of its properties. Now, do you see the player prefab field here? Drag our player prefab into that field. That will tell the Network Manager that when it's time to add a new player to the scene, to use that prefab when they spawn the player in. Now that that's done, we should delete the existing player from our scene hierarchy. Right there. Next, we'll create an empty object in the scene and name it Player Spawn Point. Now we should place this where we want our player to spawn. And so I'm going to just place it at 0, 0, 0. And if you focus on it, you'll see that puts it here. You know what? Actually, let's move it over here a little bit. There we go. Now, on this object, we want to add a network start position component. We will want to make one of these player spawn points for every location in our world where a player joining the game could spawn. So for example, if we wanted this to be a 2-player game, we might want to duplicate this and just drag the other spot over a little bit so that our players start standing next to each other. Okay, let's save the scene really quick. Better safe than sorry, right? Now if we hit play, we should see the player spawn in, though our camera and movement controls aren't working right yet. And here you can see our player. So at that point, we can cross the second task off our list. Our player is now on the network. Now we just need to make it network aware. So let's go back to the Content Prefabs folder and select our player prefab again. This time we want to go down to the bottom and we want to add a new component called the Network Transform component. This will allow us to keep its location in the world in sync across all of the clients without having to write our own code for verifying location and etc. Now let's go to Scripts, Framework, Management, and open the base player controller. Here we want to go down to the onStart method, and directly beneath it we want to add a public override void onStart local player method. Now, in the onStart method directly above it, let's cut the line subscribing to the base input manager movement input event and paste it into our onStart local player event. And then let's do the same for init attacking. Okay, now let's save the file. Now back in Unity, let's go to Scripts Framework Camera and open the base camera. As with the base player controller, we'll need to add the using Unity engine.networking using directive. Now we want to go down to the awake method and we want to find the line where it assigns the player, and we want to remove this line. We have to do this a different way in a multiplayer game. Next we want to go down to the fixed update method and we want to replace its contents with the following code that I'm going to paste in. This tells it to call a new method we're about to write called findPlayer, and if the player variable is not set, then don't call followPlayer. This will make the class a little bit more stable in the event that it can't find the appropriate player. Now at the end of the file, right beneath followPlayer, we're going to want to add a new protected virtual void method called findPlayer, and in it we're going to want to place the following code. And so what this code does is it gets every object in our scene that has the player tag. If there are objects to check, and if there's more than one, it will then go through each one and check to see if it's the local player, using network behavior's isLocalPlayer flag. If that flag is set, we know that's the player for the local client, and we can set our _player variable to that value. If, however, we cannot find a valid player this way, we simply leave player set to null so that our previous checks here in fixed update will prevent any bugs from occurring by running code without valid variable data. Now let's save this file and open the third-person look camera 3D file in Scripts Framework Camera. First, let's fix a long-standing bug. Remove the crosshairs variable at the top of the class. Now, in the onStart method, we're going to remove the code that sets the camera target variable. Much as with our base player controller, we need to look for the local player's camera target here. So we have to do this in a different way. So we want to get rid of these lines right here. Once that's done, we'll head down to roughly line 70 and replace the camera's pitch and yaw code with the following network aware version. Here you can see the pitch and yaw code. We'll remove that and replace it with the following. Mostly, this will tell the camera to find the local camera target, but it will also prevent the camera from attempting to use invalid data when there is no camera target to be found, which again will make our game more stable. Let's go to the followPlayer method and replace its contents with the following code. As before, this will tell the camera to find the right camera target before attempting to position itself behind the player, and will refuse to attempt following the player if there is no camera target. So now it's time to build the findCameraTarget method this code relies on. At the end of the file, make a new protected virtual void method called findCameraTarget, and I'm going to paste the code for this method in right now. Okay, so let's fix each of those now. This line here is no longer necessary, so this can just get removed. Now here, you'll see the red squiggly line under network behavior, and this is because, go back to the top of the file, we'll see that we forgot to add the using Unity engine.networking using directive. Once we do, the problem goes away and we can save the file. All right, so next we want to go to Scripts Framework Management, and we want to open the Player Controller 3D script. Just so we don't forget, we'll start by adding the Unity engine.networking directive. Next, after onAwake, we'll add public override void onStart local player. And to this we'll add a new line that calls base input manager.action event using this as the sender, and a new player action event args containing player actions.spawn done as the message. And just to be safe, something we really ought to do is first check to see if base input manager.action event is not equal to null. Now, we're not technically done with this file, but at this point we can knock yet another task off the list. The player is now network aware. But we need this file for our next step, firing weapons over the network. So let's just press on. Find the attack method and add the command attribute. This will help tell Unity that this command needs to run on the server. To make that official though, we need to add the CMD prefix to the method's name. So rename the method command attack. Use your IDE's refactor or rename feature if it has one. Otherwise, make sure that you also change every reference to this method in your existing code as well. I use the free version of Visual Studio, and its built-in rename feature does all of that for you. Once that's done, save the file. Now, back in Unity, we'll go to Scripts, Frameworks, Interactable Weapons, and we'll open Projectile Weapon 3D. Once more, we'll add our using Unity Engine.networking directive at the top. And then next, we're going to look at the end of the fire projectile method, which is roughly on line 110 here. We want to add the following line of code: network server.spawn _ proj obj. Now let's save the file and head back to Unity. Next, we want to go to Content, Prefabs, Projectiles, and we want to select the bullet prefab, and we want to add a network identity component. While we're at it, we'll want to add a network transform as well. Okay, next we'll want to find the rocket, and we will want to do the same. We will add a network identity, and then a network transform. Okay, let's save the project, and while we're at it, scratch firing weapons over the network off the to-do list. We're almost done. Next we want to go to Scripts, Framework, Character, and open the player controller attacking CS file. As usual, we will add our using Unity Engine.networking directive at the top, and then we want to find the health variable at the beginning of the class. We want to add the SyncVar attribute. The SyncVar attribute tells the server that it needs to let every client know the value of this variable when it changes. All right, now that that's set and we have our health being tracked across all connections, let's save that file, and then let's go back to Unity and go to Scripts Framework Manager, and let's open the Player Controller 3D CS again. Now here we want to find the onTriggerEnter event here, right about line 80. And we want to add the server attribute. This tells Unity that this should only be run on the server and should not be run on clients. And now, congratulations, we're done.